Good day to everyone. Our topic for this lecture video is about fuels and combustion, and we will discuss in this video the combustion of fuel oils and gaseous fuels. We have discussed in our previous topics the definition of combustion, the weight of theoretical air for combustion of solid fuels, which is equal to this equation, MO over MF is equal to 2.67 C plus 8 times H plus 1 times sulfur minus oxygen, where these elements are taken from ultimate analysis in decimal, and MO is the mass of oxygen and MF is mass of fuel. To get the theoretical air, we divide this by 0.231 kg of oxygen per kilogram of air. We have arrived on the standard equation of WTA equal to 11.53 C plus 34.36 H2 minus O2 divided by 8 plus 4.32 S. Now we go to gaseous fuels. These are the example of gaseous fuels like hydrogen, methane, natural gas. Their density are given in this table and also the higher heating values. Of course, this is approximate higher heating values because higher heating value depends on the location where the gaseous fuels are formed. In this slide, these are the example of liquid fuels like the familiar fuels in our country: diesel, gasoline, kerosene, and also the oil vegetable or the biodiesel. So these are the density and the higher heating value of the fuels. So let us discuss hydrocarbons. So hydrocarbons, these are any of a class of organic chemical compounds composed only of the elements carbon and hydrogen. So pag sinabi natin hydrocarbons, ang meron lang sa kanilang element ay carbon and hydrogen. In these are the example of hydrocarbons in alkanes. These are methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. The chemical formula for these alkanes is this one: C sub N and H sub 2N plus 2. So if N is equal to 1, then 2 times 1 equal 2 plus 2 equal to 4. So that is methane. If N is equal to 2, that is ethane. So you can find this one in this reference. You can visit this in the internet. So what are hydrocarbon gas liquids? Natural gas and crude oil are mixtures of different hydrocarbons. Hydrocarbons are molecules of carbon and hydrogen in various combinations. Hydrocarbon gas liquids or HGLs are hydrocarbons that occur as gases at atmospheric pressure and as liquid under higher pressures. HGLs can also be liquefied by cooling. So itong HGLs na ito yung mga hydrocarbon na pag nilagay mo siya sa atmospheric pressure, in-expose mo sa atmosphere, they are in gas form. But when they are being compressed or subjected to higher pressure, if you put them in a tank or a container and you subject that to higher pressure, they turn into liquid. HGLs are categorized chemically as alkanes or paraffins and alkanes or olefins. So these are the example. Alkanes is ethane, propane, butanes. Alkanes is ethylene, propylene, which has a chemical symbol of this one here, and this is also here. So you can visit http www.eia.gov for more information about hydrocarbon gas liquids. So let us go further for the familiar fuel oils in our country like gasoline. So what is the chemical formula for gasoline? So according to Eric Stopper, gasoline contains essentially all classes of hydrocarbon in the C4 to C12 range. but is dominated by aromatic compounds, with the alkyl benzenes being the most abundant and with a lesser abundance of naphthalene-based and ethene-based compounds. So, ang gasoline pala ay mixture siya ng hydrocarbons. According to Thorstein Kalsmiths, gasoline is a mixture of several hundreds of hydrocarbons, alkenes including cycloalkenes, alkenes, and aromatics. So, in short, there is no specific formula for gasoline because petrol is not a single compound. It is a mixture of different compounds. So, wala siyang specific formula yung gasoline. Hindi tulad ng methane na hydrocarbon, mayroon siyang CH4. So, yung petrol or gasoline, we cannot find a single specific formula for that. You can visit sciencedirect.com. How about diesel? What is the chemical formula for diesel? According to Hood, it is a product from crude oil in the distillation window between 200 degrees Celsius and 350 degrees Celsius. So, yung distillation process, yung diesel ay na-extract siya between 200 and 350 degrees Celsius. It consists of approximately 75% aliphatic hydrocarbons with a chemical formula of C10H22, C15H28, and about 25% aromatic hydrocarbons, benzene or styrene. The typical atomic mass concentration are about 86% carbon and 14% hydrogen, and a minor fraction of sulfur depending on crude oil source and cleaning quality. The heating value is about 42.6 megajoules per kilogram, and the density from 0.82 to 0.86 kilogram per liter. So for diesel, heating value also varies, but it depends on the source of the fuel. The average chemical formula for common diesel is C12H23, ranging from approximately C1020 to C15H28. So, ito yung magiging average formula niya. Kasi pwede siyang C10H20 hanggang sa range na C15H28. So, you can visit these sites for further information. How about LPG, the liquefied petroleum gas, which is also familiar in our locality? LPG is a byproduct of the refinery process. It consists mainly of propane, C3H8, and butane, C4H10, but may in addition contain some of the unsaturated components, propane, C3H6, and butane, C4H8. The composition of LPG from its individual component is not fixed. So, just like diesel and gasoline or petrol, LPG has also no fixed composition. LPG might consist almost entirely of propane, but could also contain more than 50% butane. So, pwede daw ang LPG na ganito ang composition niya, purely propane, C3H8. Now, another one which is popular in our locality is the acetylene. The publication industry uses acetylene for many major applications. It is the only fuel gas that can be used for welding. It is also ideal for brazing, cutting, flame gauging, spot heating, hardening, texturing, cleaning, and thermal spraying many materials. It is created by mixing lime and coke in a blast furnace. The product manufactured is calcium carbide. It is reacted with water to create acetylene gas, and this reaction can be easily formulated as CaC2 plus 2H2O equal to C2H2 plus CaOH2. Acetylene, calcium hydroxide, and heat are the products of this reaction. So, by definition, acetylene is formed by combining calcium carbide CaC2, and water. This reactants forms acetylene, which is C2H2, and calcium hydroxide. This one, CaOH2. So this one was balanced. Originally, CaC2 plus H2O, and C2H2 plus CaOH sub 2. So to balance the equation, we have Ca calcium here 1, then we have calcium here 1. This 2 here is only for OH because it is closed with parentheses. So carbon 2, so we have carbon 2 here, so the carbon are balanced. Hydrogen, we have here H sub 2, that is 2, and we have another one, H sub 2, so that is 4, 2 plus 2. So we have here H2 times 2, so hydrogen is balanced. And oxygen, here we have 2 oxygens, so we have also here 2 oxygens, this one, 2 times this oxygen. So this means that 1 volume of calcium carbide plus 2 volumes of water generates 1 volume of acetylene and 1 volume of calcium hydroxide. So this carbon carbide is produced by mixing lime in coke in blast furnace. So this one, calcium carbide, created by mixing lime in coke in a blast furnace. The product manufactured is calcium carbide. Then it is reacted with water to form acetylene and calcium hydroxide. So what is this calcium hydroxide, another product of this reaction? So one is acetylene and other is calcium hydroxide. This is traditionally called slaked lime. It's an inorganic compound. It is a colorless crystal or white. It has many names including hydrated lime, caustic lime, builder's lime, slack lime, cal, and pickling lime. So this is the picture of the calcium hydroxide. Sa ating lugar, ang tawag dito ay kalburo. There is one plant here in our locality near Naga City. It is in Magaraw. The plant is called Magaraw Air Products, I think. They are manufacturing acetylene, and which is given free to the public is this one, yung kalburo. So makikita nyo yan sa Magaraw. Now let's go to stoichiometry. Okay? Stoichiometric combustion is a theoretical position in which the optimal amount of oxygen in fuel mix generates the most heat possible, and maximum combustion efficiency is achieved. For natural gas and most gaseous fuel, it is normally indicated by volume. Now let us take an example, this one, propane. Propane is an organic compound and paraffin hydrocarbon similar with ethane or methane. The chemical formula of propane is C3H8. So we have now this C3H8. Then we add oxygen, O2. So the product of combustions are, of course, carbon dioxide and water. So balancing the carbon, we have 3 carbons here and 1 carbon here. So we multiply this by 3, this term, to balance the carbon. Next, the hydrogen. We have 8 hydrogen here. We have only 2 hydrogen here, so we multiply this by 4. So we have now 8 here and also 8 hydrogen here. Then balancing the oxygen, we have 4 oxygens here plus 6 oxygens in this term, 3 times 2. So we have a total amount of 10 oxygens on the product of the combustion. So we multiply this by 5. So now, the formula is C3H8 plus 5O2. And this becomes 3 carbon dioxide plus 4 H2O. So we write that here, the product of combustion and the reactant. So what does this mean? So this means that 1 mole of propane, C3H8, 5 moles of oxygen, then it becomes 3 moles of carbon dioxide and 4 moles of water. This is in moles. So this is how you read this one, this equation. Okay? Or in kilogram, the same with the discussion in a previous lecture video. So we find the molecular weight or the molecular mass of these elements, and we multiply it by the subscript and the coefficients. For example, for this one, C3H8, carbon is 12, so 3 times 12 is 36. Hydrogen is 1, so 8 times 1 is 8, so 36 plus 8 is equal to 44 kilograms. So this is 44 kilograms of propane. Oxygen is 16 times 2, that is 32 times 5, then 160 kilograms of oxygen. This is combustion using pure oxygen. We are not yet using the atmospheric air, but the pure oxygen, because atmospheric air has nitrogen component. We don't include that here. We will check that later. So for product of combustion, we have 3 carbon, that is 3 times 12 is 36, plus 2 times 16 times 3. If we total that, we have 132 kilograms of carbon dioxide. And for water, we have 8 hydrogen plus 4 times 16, 64 oxygen. So 8 plus 64, 72 kilograms of water. So ganon kinukuha yung in kilogram. But in volume, if you will read this in volume, this is 1 volume of propane plus 5 volumes of oxygen is equal to 3 volumes of carbon dioxide and 4 volumes of water. The same with moles. But in terms of mass, you multiply this by the corresponding molecular mass of each component. So, in short, there are 160 kilogram, or we need 160 kilogram of oxygen per 44 kilograms of propane. So this is your oxygen fuel ratio, or 160 divided by 44 is equal to 3.64 kilogram of oxygen per kilogram of propane. So this is combustion using pure oxygen. Kaya nga meron tayo ditong oxygen per fuel, which is propane. So combustion using air, you divide this by 0.231 kilogram of oxygen per kilogram of air. This is constant. So if you will notice, kilogram of oxygen and kilogram of oxygen will cancel. So this kilogram of air, which is the denominator of this one, will go up. This will go down. So we have kilogram of air per kilogram of propane. So this is combustion using air, and this is combustion using pure oxygen. Now we go to other solution. Combustion using atmospheric air. We will include nitrogen. Since air is 79% nitrogen and 21% oxygen, therefore by volume, we have 3.76 nitrogen per oxygen. So, yung air, meron siyang 79% nitrogen and 21% oxygen. So, ang ratio niya, ang isang volume ng air, meron siyang 3.76 nitrogen per 1 volume of oxygen. So, writing again the chemical formula for propane, C3H8, we add O2, oxygen plus this term, 3.76 into. So this one, O2 plus 3.76 into is now what we call atmospheric air. Yung kanina, ito lang, oxygen lang. Now we are using atmospheric air, and atmospheric air is composed of O2 plus 3.76 N2. So, huwag nyo kakalimutan to. So, write down the product of combustion. So, same. The product are carbon dioxide, water, and of course, 3.76 nitrogen. Itong 3.76 nitrogen na ito, after combustion process, hindi yan magbabago. Hindi yan nagre-react. It is still 3.76 nitrogen in the product. So, wala siyang pagbabago sa process. Okay. So, you balance the carbon. Same with the procedure we have on our previous slides. So, babalansin mo yung carbon. Then, balance the hydrogen here. So, that's why we multiply this by 4. And balance the oxygen. Now, in balancing the oxygen, we have here 10 oxygens, right? 3 times 2 is 6, plus meron tayo ditong 4, so 10. Okay? So, to make this oxygen 10, in the reactants, we have O2 here, we multiply this by 5, similar with the procedure in the previous slide. If you will go back to this video, same lang yun. Ang nagkaiba lang dito yung may nitrogen kasi siya. So, yung 3.76 nitrogen, siyempre, nagdagdag ka ng 5 times the amount of the oxygen, you will also multiply 5 times the amount of the nitrogen. So, para yung atmospheric air mo ay lagi siyang kumpleto. So, nagdagdag ka ng oxygen, magdadagdag ka rin ng nitrogen, siyempre. Kasi, para balance siya, para palagi siyang with accordance with this ratio. So, if you multiply 5 here for oxygen, you also multiply 5 for nitrogen. And also, you multiply 5 for nitrogen in the product of combustion. So, by simplifying, 5.376 is 18.8. And also here, 5.376 is 18.8. So, what does this mean? So, 1 volume of propane plus 5 volumes of air. So, why 5 volumes of air? Because this one. This is your air. So, we multiply this by 5. So, 5 volumes of air. Equal to 3 volume of carbon dioxide plus 4 volumes of water plus 18.8 volumes of nitrogen. So, this one. Okay? So, I hope you understand this one. Or, in molecular weight, 44 kg of propane to 160 kg of O2. This was found similar with the previous slide. You multiply the subscript by the molecular mass or molecular weight. And 526 kg of N2, that is 18.8 times the molecular mass of nitrogen equal to 14. 18.8 times 14 times the 2, the subscript. You got 526 kg. So, the same goes with this one in the product of the combustion. So, what does this mean? 44 kilograms of propane plus this is your air. So, sabi natin, ito yung dinagdag natin yung air. Hindi siya pure oxygen, kundi air. Yung ginawa natin dito. So, this is your total air. 160 kg of oxygen plus 526 kg of nitrogen is your air. This is the 5 volume of air na dinagdag mo. So, this becomes 160 plus 526, 686 kg of air. And we have a total of 730 kg as the product of combustion. So, sinum up mo lang ito, 526, 72, 132. So, these are the product of the combustion. Now, by simplifying, we have 686 kg of air to burn 44 kg of propane. So, 686 divided by 44, 15.6 kg of air per kilogram of propane. So, this is our wata, weight of theoretical air. So, in our first solution, we have computed 15.74. kilogram of air per kilogram of propane. So we have here 15.6. So there is a discrepancy, minimal discrepancy in decimal because of the rounding of numbers. For example, we have just multiplied 14 instead of 14.0067 for nitrogen. And this one is also, this 3.76 is also rounded off. So that is not exactly 3.76, 79 divided by 21. So there are decimal places here. So there is a discrepancy because of the rounding of numbers. We got here 15.74 and we got here 15.6. Now, let's go to example 2. And we will take acetylene as our fuel here, C2H2. Now, let us solve first using atmospheric air. So, C2H2 plus this is the atmospheric air, O2 plus 3.76 into. So, the product of combustion is carbon dioxide again, plus water plus the nitrogen, 3.76. So, balancing the equation, carbon, we have here 1 carbon, we have here 2. So, we multiply the carbon here by 2 in the product. So, carbon are equal. For hydrogen, we have 2 hydrogens here. And we have 2 hydrogens here. So, hydrogens are equal. Oxygen, we have 1 oxygen here plus 4 oxygens here. So, we have here 5 oxygens. Right? So, in the product of combustion, we have 5 oxygens. 1 plus 2 times 2. So, that is 5. So, here we have only 2. So, to make it 5, we multiply it by 2.5. So, 2.5 times 2 is 5. So, since we multiply oxygen component of air into 2.5, we will multiply also again 2.5 for the nitrogen component of atmospheric air. So, if you multiply 2.5 here to balance the equation, you multiply also 2.5 here in the product. Then C2H2 is equal to 2.5 times O2. If you multiply this, 9.4 nitrogen. So, you copy this one, and you multiply this, 9.4 nitrogen. So, this is 1 volume of acetylene plus 2.5 volume of air. So, this is your air. This is 2.5 volume of air is equal to 2 volumes of carbon dioxide plus 1 volume of water and 9.4 volume of nitrogen. Or in kilograms, so we have here the reactants, acetylene, C2H2. So 2 times 12 carbon, 24 plus 2, 26. And oxygen, 2 times 16 times 2.5 is 80. Nitrogen, 2 times 9.4 times 14, 263.2. So, this one is also found by the way we found this one. So, we have here 88 kilogram of carbon dioxide plus 18 kilograms of water plus 263.2 kilograms of nitrogen. So, this nitrogen is 2 times 14 times 9.4. That is 263.2. So, if you total this one, we have 369.2 kilogram product of combustion. While the reactants, we have 80 kilograms of oxygen plus 263.2 kilograms of nitrogen. Then it becomes 343.2 kilograms of air. So, to compute for the air-fuel ratio, kilogram of air per kilogram of fuel, which is acetylene, we divide 343.2 kilograms of air over 26 kilogram of acetylene. And this becomes 13.2 kilogram of air per kilogram of acetylene. So, this is our air-fuel ratio. We can also compute this one using pure atmospheric air and you divide by 0.231. Same with the discussion here in this page, in this slide. So we use oxygen and we arrive for the oxygen fuel ratio here, and after that you divide it by 0.231 oxygen per kilogram of air to get the weight of theoretical air. So pwede rin ganun yung solution nyo dito sa example na ito, and you try this one. So that's all for this video. I hope you understand the discussion in this video, and if you don't understand, just watch again this video. Our next topic will be flue gas analysis. We will concentrate on the product of combustion. So here we have concentrated on the theoretical air, the reactants. Our next video will concentrate on the product of combustion, especially for coal. Okay, that's all. Thank you.